Hello and welcome to the Damage Prevention channel. My name is Kevin Goldblum. I'm your host today. Today's topic is going to be SUS, which is Subsurface Utility Engineering. We have today Bill Kiger. Bill is the president and CEO of Pennsylvania 811. And we have Nick Zembillas, who is CEO of Subsurface Utility Engineering LLC. Nick is an international subject matter expert on subsurface utility engineering. Well, welcome today. And first of all, could you please tell me a little bit about yourselves and your expertise on the matter, Bill?
Thank you, Kevin. I'm Bill Kiger. I'm Executive Director, CEO of Pennsylvania 811. I've been involved with Pennsylvania 811 since 1974, and I've been interested and pushing subsurface utility engineering since the mid-'80s when it actually began.
Great. And Nick, tell us about your expertise.
46 years in the industry, started my career with the Florida Department of Transportation, tied to utility coordination and construction management. And my remaining years were approximately 36 years in subsurface utility engineering in the private sector.
Great. And so that's going to bring us to the first initial question here to let our audience know what exactly is subsurface utility engineering.
Yeah, we'll start with SU. SU is a profession practice in which we apply three disciplines of professional disciplines, and that's engineering, civil engineering, geoscience, geophysics, and surveying. And you combine those three to investigate and explore and find underground utilities, because we often find that the utilities are not so often accurately depicted on the drawing. So we practice those three disciplines to produce a SU process that helps identify utilities in a more comprehensive and accurate manner.
Great. And is this SU bill a requirement in the Pennsylvania One Call law?
Yes, Kevin. The subsurface utility engineering responsibility began in 2006. And it requires the project owner to use the sufficient level of subsurface utility engineering for the project that they're on.
See, I understand that SU has some specific standard guidelines for investigating and documenting existing utilities. Can you explain those guidelines to the audience?
Yes. In 2002, prior to that, we practiced SU without a standard of care. And in 2002, we were able to, as a committee of industry practitioners, to develop the first American Society of Civil Engineering standard on subsurface utility engineering, which was called ASCE 3802.
The 3822 guidelines have our different quality levels. Can you explain what those quality levels are and how they're used during the design process?
Sure. There are four quality levels, and they're basically a level of applied effort with applied best practices. And so we start with, it's like a report card. Instead of the A, B, C, D, it's the reverse. It's quality level D is the initial phase of investigating, doing your due diligence on gathering information on a specific project and the utilities that may be impacted on that project. And that's a process which mostly involves utility coordination, dialing 811 to gather information on the utilities, and then along with going on the site and doing some investigation, meeting with utility companies to gather information only, which could be someone's depiction of here's where our facility is, to records, sketches, and from that information is the starting point of the SU process. From there, depending on the nature of the project, determines as to what next level you'll take. So let's say we talk about the complex projects. Those are the most predominant ones that create our issues. So there we take the information and we then go out to the field to observe and collect information on those known features of the various types of utilities that we can see. And we'll survey them. We'll survey the inverts of a storm drain or of a sewer line. And that information combined with your quality level D gives you a level of confidence that says, okay, taking the quality level D, which is information only, went out and saw what I could see, And they stopped there and they put that information on the drawings. What is missing, though, is what happens between known point to known point, in which all you took was that information and shot it. And then we realized in the old practices that those were just straight lines drawn from one intersect to another intersect. So quality level B came into the equation. And that quality level B is where we started to apply the advanced geophysics, the variety of geophysical technologies to help detect, image, and collect the actual utilities in their locations, or horizontal locations. And from that, we were able to then enhance the SU process by providing that information into the project delivery process. And now we had a clearer depiction of where those utilities were now from a two-dimension horizontal. And as a project design progresses, now engineers and designers are needing to know, we need to know specifically where are those utilities, because what we're proposing to design, we have to know the horizontal, vertical, and the characteristics of that utility so we can determine whether we have a conflict or not. And that's quality level A. And that's where we use geotechnical technologies, and we do non-destructive excavation to expose the utility and collect all that information from a surveying perspective as well as from the physical features of that utility as far as its condition are concerned. You combine all of those four processes, and each time you combine them, and you've got now all four on one project, and you've produced that SOUP process to achieve a project deliverable, your level of risk is diminished with the advancement of the various quality levels that you incorporate, to where you've got a project now that's done a good job of trying to eliminate the potential conflicts during construction.
Okay, that makes sense. So you're trying to do everything possible to make Pennsylvania safe before the excavator actually goes out there and sticks the bucket into the ground.
Well said, yes.
Great. And now, with these quality levels, how do you incorporate that into Pennsylvania One Call's design program?
The law went into effect in 2006 that incorporated the project owner's responsibility to use sufficient level of underground utility engineering. That process has been in place and been around for decades. 1986-ish was the time that it started gaining traction. There's many cost studies out there that Nick can fill you in on some of the detail for that. But the process is a requirement, and it starts in a very low area, which Nick explained, the quality level D, and I look at them as steps. You essentially weed out the problems you're going to have by using the lowest level of SU, so that you can then narrow down for the next step, so your C is covering a smaller area. Unless you're dealing with a PennDOT or a Department of Transportation project where they're doing curb to curb or right-of-way line to right-of-way line, so that they have to see the entire scope of everything that's there. And that's probably the most involved project that a subsurface utility engineering professional would have. And then again, going to the B, where you're actually involving the utilities in locating the lines and finding the approximate location. Whereas under Pennsylvania law, you go through those processes, but before final design, which is no less than 10 or more than 90 days prior to the actual bidding of the project or giving it off to construction, that has to be done to a quality level A for those areas where you've found already the potential of a conflict.
Bill's spot on, as we say. And I have to give Bill a lot of credit, because I've known Bill for over 35 years. And he and I have grown in our respective professions, and we've been very good about, as subsurface utility engineering came upon in 2002, it was Pennsylvania that was probably one of the leading states that took that process and applied it to their projects. And with Bill, and being in the damage prevention industry, that industry was one of the first proactive states to enact a law that related to the use and application of subsurface utility engineering. So Bill's spot on. His theories and the process is accurate. And that it opens our eyes to realize that there are many types of definitions of complex project. You can have a complex project that is, like Bill said, tied to the Department of Transportation, the nature of the project and its complexities. But there are also complex projects in the designing and constructing of underground utilities in which the nature of their complexity has a process of its own that does apply the SU quality levels to make it be applicable for the nature of that type of complex project and utility that's being installed in the ground. So to me, they are genuinely applying the SU process and the American standard in a way that's fitting for the nature of that complex project. Well said, Bill.
And then, now that you have these quality levels, what application would you use on the Pennsylvania One Call website to actually enter this in for the design?
Well, I think first of all, Kevin, you would want to put all that information onto a drawing, and then you would make the notification through a system we have built beginning in 2017. We introduced Coordinate PA. We have 33 coordination committees across the state that work to prevent damage and to work collaboratively across the state. And each and every one of those can then review this process, go through the actual project itself, and monitor what's going on step by step by step throughout the project to reduce damage, to improve the communications, and all of that can be captured electronically on our Coordinate PA. We also have the ability to actually take those drawings, which you are required to send the drawings to the utilities through the One Call system. And so you can do that electronically. They will mark up their facilities and affirm that they are in the place that you found them, and then take that information, put it on the system, and then once all of the utilities involved have done their job, that drawing will be sent back to you electronically, and you can complete your drawing for the final design process that we talked about earlier.
So 3822 defines the guidelines for excavating and documenting existing facilities. Is there a standard for recording and exchanging utility infrastructure data?
Yes, there is. In fact, it was published in 2022. It's called 7522, and it is the next dimension of after you've applied ASCE 38.2 in the SU process for a project delivery. It's about now documenting and collecting, as we call it, as-builts, but as-builts that fit to the same criteria of collecting the information, documenting the information, and the characteristics information that you would put to create an as-built drawing. And so that ASC 7522 is now that phase of doing that. And the exciting news is that in Pennsylvania, there's already discussions with Bill and Coordinate PA, and he welcomes the integration of that work product into their system, and we hope that other states will, such as, I think Colorado's one, but there are other states that will look at that. But we've got to develop a national as-built process, and this is the first step.
This is the first step? Okay, very good.
Well,
Yes,
going
sir?
in that same direction, the as-built information under the law, the project owner should submit that to the One Call Center as an as-built when the project is done. That allows the utilities to come back and capture their specific location more accurately, so that then the next time they have to deal with this, they have more accurate information. And accurate utility records are extremely important to the locator and to the excavator that's doing the work. The work should be clearly presented to the excavator so that he can bid appropriately. He's got to know all of the encumbrances that he's going to face as he goes through the project. That should not be a burden on his shoulders. That is the responsibility of the project owner and the designer to build that specification, if you will, so that he can bid more accurately and more precisely and save that project owner a lot of money.
What kind of problems might the excavator face if the SU process isn't done beforehand?
Well, if you're working down a particular street and you run into a, let's call it a blocking, so they have blocks on water lines where they make a bend or they change size or have a large valve so that that valve doesn't move because the water in the line changes pressure pretty abruptly sometimes, and it's very important that that not go anywhere when it does that. You also have the freeze-thaw issue in Pennsylvania, which you may not have in Florida, as Nick knows well. So that freeze-thaw cycle that happens throughout the evening and also in the morning as the temperature rises or falls, that there's a movement of the earth, slight in many cases, but enough that it actually pushes the pipe towards the surface over a period of time. So anything you can do to keep that pipe where it belongs needs to be done appropriate to the conditions that you find. That whole process, again, needs to be presented throughout the actual construction process. And I mentioned the pre-construction meetings and what's required, but post the initial meeting, you should do that on a regular basis so that whether it be monthly or every X weeks, then it keeps things live in the locator's mind, in the utility's mind, in the project owner's mind, and all that are involved in that project can see that information, and it's recorded on the CPA site and can be exchanged for those that aren't able to make a meeting. The first meeting is required under the law. So facility owners that are involved in that project must attend the meeting and must come to an agreement with the contractor on a locate schedule, on an agreement on how the project's going to roll out. If there are any changes, those have to be communicated through that, and additional tickets might need to be added at that point in time. All of that can be done through CPA. But the collaboration and communication and the cooperation can save a significant amount of money. One of the local municipalities in western Pennsylvania, Bellevue Borough, was able to save 50% of their paving costs as a result of working with Columbia Gas as they built replaced their pipelines, and Columbia Gas saved 50% of their paving costs because they were able to use the same contractor that was doing the Bellevue project at their rate rather than having to have a contractor come in and mobilize and do the paving separately.
Okay, so there is a lot of savings there. Do you have any examples where you saw savings too?
Yeah, I can give you the approximate. I don't have the exact numbers, but the first SU cost benefit study was done in early 2000, and it was commissioned by the Federal Highway Administration, and they commissioned Purdue University. And when they did their study, it was to look at only the Department of Transportation's project items, not to look at the utilities and their impacts. And their study audited 71 projects, and it yielded $4 and change for every dollar spent. So as time went on and we developed the engineering standard ASC 3802, we had two studies that were done that were part of another Pennsylvania. It was University of Pennsylvania that did one and did both of them. Now, the latest one was incorporating the cost and impacts as it relates to the utility relocation, in addition to the Department of Transportation's items of construction. And that study yielded a 22 and change for every dollar spent. So my assumption is to look at that we now had an applied standard, best practice, from 2002 to 2000, I think that was in late 2000, and that had the best practices being applied in the project delivery process. So to me, it kind of reflects to me that, okay, we're seeing some better cost savings and on all sides of the stakeholders. And then Toronto did one in the early years, and that was around $11 and change. And I could be wrong, but there's been overall 4 studies. Now we are seeking now as a professional association called the Subsurface Utility Engineering Association. We are talking to the federal government, Federal Highway Administration, to help. We need an updated standard, an updated return on investment study to look at now that we've got the standards in place and we've got more DOTs applying it, to see if we can get a more comprehensive, up-to-date cost-benefit study.
Right. Well, is there anything else that you'd like to add, being that you are the international subject matter on subsurface utility engineering?
Well, I think we have to look at, now that we've got the two standards, the SU standard as well as the as-built standard, and start to look at training and developing the associates, the engineers, the technicians in the industry, because it's now about making sure that we apply the standard of care in a unified way. And we have now institutions that are doing that. We've got BAMI International. We have 2 universities that are providing certified courses to help those practitioners, whether you're a professional or non-professional, to come and get trained on the theories and principles of and best practices of the various technologies that are being applied. And so I see that as the future. And the more we do that, we are seeing some of our clients that are requiring the use of SU on their projects per the standards, and they're even pre-qualifying firms and pre-qualifying individuals in order to qualify them to be able to do business. So that's good. We want to see more of that. We want to see more of the contractors that are now very keen on the use of SU on projects. They're an advocate. We have the AGC, we've got NUCA, who both support the practice and the application of SU on projects. So they're encouraging their project owners out there, hey, we need to see more SU on projects. So more training, more development, and technology is advancing as fast as we can. So from not just from the engineering, but from the geophysical side and the geospatial side. We're seeing now in the industry now that we've got people, practitioners in the field, practicing and collecting information in real time, sending it to the cloud. And from the cloud, the project manager, the project engineer, the project designer is able to retrieve that information, and from that, continuously designing their project. And from there, it goes to construction, to where you're seeing now that that's being used, and drawings are now digital drawings, and you can actually go out and actually image and see your utilities in the ground where they are. So that, to me, is the technology is advancing significantly. So that's the future, and we're there now when it's progressing.
Right. Well, that's a very exciting future, it sounds like. And Bill, is there anything else you'd like to add about the SU process and how it relates to PA1 call?
Yes, Kevin, I'd love to do that. The SU process pays many benefits, and one of those is the ability to collaborate and coordinate these efforts with accurate information. The process can be used by our coordinating committees if we all work together, as we did back in the World Wars and other activities that we've done together. We solve these problems, and we can move forward in a much quicker and a less expensive way to build the new infrastructure that we're doing as a part of a national effort. This infrastructure has been there for sometimes. I've seen stories of lines being taken out in the Philadelphia area. There was a line put in there in the early 1800s that was still being served. It was a tree trunk that was fashioned into a 5-way intersection or cross connect, and it had served for almost 200 years. So obviously our infrastructure is old and in need of help, and working together we can solve those things more quickly. We can eliminate or reduce dramatically the amount of paving necessary and the disruption to the public. All those things can pay dividends as we move forward into the next century.
Bill, thank you for that insightful answer. I've learned a lot today. I hope our audience has learned a lot today too. Bill and Nick, I just want to thank you so much for joining me today. I hope you both enjoyed your time, and please come and join us again on the Damage Prevention channel so we can teach the audience more information about subsurface utility engineering.
Appreciate that, Kevin.
Our pleasure. Thank you.
Thank you.